Hey guys, welcome back for week 6, the beginning of the second half of your summer math. Where we left off last week had a lot to do with starting algebra and figuring out if there's a missing number, how can we work with the problem to solve for that missing number. You will do a lot of that next year. I didn't want to do any more practice on that this week. I wanted to show you why we did the stuff last week, the importance of finding a missing number. And that would be something called a proportion, okay? You may have heard the word proportion before. A proportion, if you want to know like what is a proportion is when you compare two things. And that's what we're going to write right here. When should we think about using a proportion? Anytime we are comparing two things. And I'm going to add to that, maybe we're trying to find a missing something, okay? So we're comparing two things, and I'm going to put in hopes of finding an unknown quantity. Okay, now remember an unknown would be like a variable, and then when I say an unknown quantity, that just means like it could be just a missing number, just finding a number for the sake of finding a number, but we could be looking for like in a word problem, if we're comparing like the number of hours we work with the money that we make. Those are two things that we're comparing, and maybe one of those is the quantity that we're looking for. So we're going to do a little bit of all of that today, and we're going to start by how do we verify a proportion? Well, before we actually do an example, okay, something that is important to know is that with a proportion, you will have two equal fractions. That's pretty much what a proportion is. So whatever fraction is over here and whatever fraction is over here will actually be the same amount. So it would be something like if I said 1/3, 1/3, and I had to compare 1/3 to some other fraction right here, okay? Well, you know, sometimes it's still the same thing as 1/3, it's just that it's written a little bit differently. So an example might be something like 4/12, okay? If I look for 1/3 and 4/12, if we're trying to figure out is this a proportion or not, you're trying to figure out are those two fractions equal? So what do you think? Do you think these two fractions are equal? I say yes they are. And the reason I say yes they are is because we can reduce this one by using what you learned in the past. We can look for a number that both of these go into. So let me divide the top by 4 and divide the bottom by 4, and you will get 1/3. So if this is possible and you are able to get two equal fractions, then you definitely have verified a proportion, and you would say yes, these are proportional. Okay, cool. So that's the relationship that they share. So let's do another one, and I'll let you see if you think that they are proportional or not. Okay, so I want you to compare, how about something like 3/5 and 15/20. Okay, so if you had to compare these two fractions to find out are they the same thing, what would you do? Okay, well, what I would just try to do is reduce them. Now, can 3/5, can that be reduced? Is there a number that goes into the top and the bottom that we can divide out? No, there's not. Okay, those are two very different numbers. Is there anything that goes into both 15 and 20 that we can divide out so that we can compare? I think 5 goes into both of those. So if I divide this one by 5 and this one by 5, it reduces down to what? What is 15 divided by 5? And what is 20 divided by 5? Okay, cool. So what would you say? Are these proportional or not? It's a big fat no. And why are they not proportional? Because these are not exactly the same. I know that the numerators, I'm going to put a big fat not equals. The numerators are the same, yay, but they have to match exactly. So since they don't, nope, not proportional. All right, cool. So now that we've talked about if you're given two fractions, how to compare them, let's talk about actually solving a proportion. So what this means, and if you can write small enough, I want you to kind of squeeze this in here. What we are looking for is solving a proportion. There will be a missing part of the fraction. That's what this is going to look like. So it's hard to really write notes over it unless we actually do an example. So I'm going to start with showing you what I'm talking about. Your directions might just say solve, okay? And then what you're going to see is something like 3 over 7. Oops, 3 over 7. That's a terrible 3. Let me fix that because it's embarrassing. Okay, 3 over 7 is equal to, I don't know, something like 6 over x, something like that, okay? So the goal would be you have a fraction equaling a fraction, and they're telling you right off the bat, it's like, yes, these are equal. You're supposed to find the missing number down here that would make these equal. And some of these you will be able to do in your head because if you notice a pattern on the top, like if you notice, oh, well, this is just the top one times 2 and that made a 6, then you could notice the same thing down here. Okay, well, 7 times 2 is 14. So that should be a 14, but I'm going to actually show you a way to solve a proportion that works on everything, even if you can't do it in your head, and it's called cross multiplying. Cross multiplying is most people's favoritist thing, I know that's not a word, from this class all year long. It's something that will stick with you and you'll use it all the way up through the next 5 years of school. And you can use it anytime you have a fraction equals a fraction, you cross multiply, and that's exactly as it sounds. I draw, you multiply across. So I draw a big old X in the middle like that. And whatever I've connected the ends to, that's what gets multiplied. So in other words, like I drew this diagonal and it's connecting the 3 with the X. So I need to multiply the 3 times the X. That would be my first step, okay? So what is 3 times X? Well, from the last video we learned it's just 3 times X. You just write them side by side, okay? Now what we do is we recopy the equal sign that was there, okay? And then we multiply across the other way. So I've already done this diagonal, so now I'm going to do this diagonal, all right? So I need to do 7 times 6. So what is 7 times 6? That would be a big fat 42. All right, cool. And now this looks something like what we did last week, where the goal is to figure out 3 times what number is equal to 42. Now if you can't do that in your head, one of the things you learned from last week's video is to get that X by itself, if there's something stuck to it, you just divide it off. So if there's a 3 stuck to that X, we divide this side by 3 and we divide this side by 3. So what is 42 divided by 3? Well, it better be 14, and in fact it is. And so that's how you solve a proportion, is using cross multiply. We're going to do one more example over here, just so you can see that these are definitely possible. Okay, let's do something like 9 over 2 equals x over, I don't know, maybe like 5? Okay, something like that, okay? Now, the reason I chose this one is because this one you probably cannot do in your head. For one thing, if you look across the bottom, I don't know how to turn a 2 into a 5 without using decimals. Then you'd have to figure out that same decimal math up here, and it would just kind of be a headache. So I'm going to go into the cross multiply again. I'm going to start with crisscrossing this way. What is 9 times 5? 45. I'm going to recopy my equals that's in the middle, and then I'm going to do the other multiplying, the other diagonal. So crisscross this way, and I've got a 2 and an x. So I've got to multiply a 2 times an x. Well, it's just 2 with an x behind it. So this should feel very similar to this over here. Now you're trying to find a number to multiply by 2 to make 45. If you can't think of that number, then do what we did over here. You've got a number stuck to the x, so you can just divide it off. And when you divide that side by 2, you have to be fair and divide that side by 2. So the answer is 45 over 2, okay? If you don't like that, then turn it into a mixed number. This is actually fine. It's either 45 over 2, or you would have to go over to the side and actually do that division. So you would get 20, let's see, that would be 22 and a half. So either way is fine if you want to do this, or as a decimal if you like decimals and want to call that 22.5. I mean, all of these are the same thing, and that's how you could write your final answer. All right, cool. So now all of this practice is just the how to do it so that you can see where we're going to get to do it. And this is going to work. This is kind of a cool lesson, guys. You're going to use this year. You're going to use it next year in algebra, and right here I'm going to show you some stuff that will also be used again when you're in geometry. So for some of you that's 9th grade, for some of you that's 10th grade. So this little lesson goes a long way. So geometry and similar figures. You probably know from last year you studied similar figures, and you learned that a figure is similar if they have the same angles on the inside and if their sides relate in a certain way. So in other words, if I take this rectangle and I shrink it by half its size, then you know the dimensions of this rectangle. Those are two similar figures. Figures. Okay, and this is the actual symbol for similar. So if you want to know how to do that, you write this little, actually, you know what, it's only one of those. There we go. That means similar if you just do one little wavy right there. And so what the picture might look like is something like this. Like you may see, well, this is a rectangle, and this is 10 units long, and this is 12 units long. And then they might say, okay, this one right here is maybe it's 2 units long, and then they put an X or something on the other one. So what they're trying to get you to do is find the missing side. And if you're trying to find the missing side, we're going to do this exactly the same way as we did above, because we are comparing two things, everybody. We're comparing a big shape to a little shape, or you can think of it as we're comparing the length of this one to the length of that one, and the width of this one to the width of that one. So I'm actually going to think of it as length and width, okay? So I'm comparing the length over the width. And if you wanted to do width over length, it really doesn't matter, okay? So how I'm going to do this is I'm going to look at this shape and set up the L over the W, just like I wrote it here. So 10 over 12. Then I'm going to put my equal sign because we want them to be similar. There has to be a relationship. Do the same thing here. Do the L over the W here. So 2 over X. So it's really just always going to be two fractions, and you just have to be kind of careful with where you stick the numbers to make sure you're putting them in consistent spots. So I used, the side over the bottom. So on this one I did the side over the bottom. Okay, so that's how we've set it up. Now what do we do? Okay, well for me, what I would do is the cross multiply thing that I showed you earlier. So I'm going to do 10 times x, which is just 10x. I'm going to recopy that equals, and then I'm going to do the other diagonal, the other crisscross multiply. 2 times 12 is 24. And now what? Now 10 times something equals 24. Well, I can't do that in my head. So what do I do with that 10? I divide it away. And if I do that to that side, I do that to that side. And what is 24 over 10? Well, it's either 24 over 10, or if you don't like that answer, you can actually divide, okay? 10 goes into 24 twice with a remainder of 4. So you could do it as 2 4/10. Some of you may notice that this fraction even reduces, and that's a pretty good thing to notice. So you could write it like that. So ask me in tutorials if you have a question about how I got from here to here. But honestly, a lot of these answers will be accepted by your teacher. It just depends on your teacher, and you'll get to ask them that next year. Okay? All right, next, so size changes. I have a photo that measures 3 inches wide by 5 inches long. Now, right off the bat, I'm going to start circling stuff, guys, because the proportion is comparing two things. It looks like in this one, it's not inches and inches, it's wide by long. You need to have two different things. So we're comparing width and length. Find the new width. If the new width is 8, then what is the new length? Okay, so first is let's take the 3 and the 5 and try to make a fraction out of them. So if you just want to do it as you read it, and we want to do W over L, then I need to keep that in mind, okay? So when I set this up, this one says it's 3 inches wide, so the 3 goes on top, just like the W's on top with what I did here. The L's on bottom, so 3 over 5 is equal to, now we read the next sentence, the new width is 8. So if the new width is 8, would that 8 go on the top or the bottom? Well, look over here. The W's on top here, and this is saying width, so it needs to go on top, and it wants you to find the new length. So you can put an X there, you can put the L there, whatever you want. I'm going to use an X. And now we do the cross multiply thing. So I'm going to go a little faster because we've already done a few of these. Okay, so this corner is 3 times X. The other corner is these two together. So what is 5 times 8? 40, okay? And 3 times something equals 40. I can't do that in my head, so I'm going to divide both sides by 3. And I'm going to get 40 over 3. Now 40 over 3 is your answer. If you don't like it, turn it into a mixed number. So 3 goes into 40. Oh gosh, is that like 13 times? I think it's 13 times with a remainder of 1. So it would look something like that. So you could write your answer like that too. All right, cool. Last example, and then you get to go and try some of your own awesomeness. Okay, comparisons. So I just paid $5 for 15 oranges. How much would I pay for 23 oranges? So we need to figure out what are the two different things that we're comparing in this problem. Well, oranges is definitely one of them, okay? But I think the other one is going to be, we've got amount of oranges and we've got money. So we've got money and we've got the number of oranges. Okay, so I just wrote M over O. You could do O over M, it doesn't matter. Just I write it out to the side so that I'm consistent on this next part. Because on the next part you actually plug the numbers in. So I need to do money over oranges. So for this sentence, money over oranges would look like that. And now for my next one, let's see what they've given me. How much would I pay for 23 oranges? So 23 oranges, would that go top or bottom? It would go bottom because over here I put the O on the bottom, okay? So I'm looking for how much would I pay. I'm looking for my money, so that needs to be the X on top. And now we'll do what we've been doing. We're going to cross multiply. Ooh, this one's not fun. The numbers are big. 5 times 23. I'm going to do my math over here. I'll just shut up and math a little bit. I'm getting 115. Is that right? I think so. So 115 equals, now I'm going to math this way. That's just 15 times X. Cool. Okay, now what? Now I can't solve that in my head, and there's a number stuck to the X, so let me divide that number off. And so my answer is whatever this is. So 115 divided by 15. So if you want to turn that into a mixed number, you'll have to do your division out here to the side, okay? 115 divided by 15. So I know that goes into 30 twice. So it goes in, 6. So I think it's going to be 7 times, but let me check that out. Yep, 7 times with a remainder of 10. So as a mixed number, this is 7 and 10/15, or you could reduce that fraction and call it 7 and 5/3. So all of these are or, so it's this or this or this. So like I said, I don't know what your teacher's going to want. I'm okay with you leaving it like this. If you've got a calculator, you can even type that in and get the decimal for it. That would be okay too. I don't know, it's not 5/3, sorry y'all, it's 2/3. Sorry, that was a mess up. But you could do that with a calculator and it would give you 7.6667, something like that. So use whatever you like, but give the homework a try now with the whole cross multiply idea, and hopefully that goes well for you.